what the final product should look like. We should have a player that can move along the x-axis. We should have six aliens that spawn randomly along our plane. And if you get a score of 6, which means if you kill all the aliens, then you win the game. I'll show you an instance of how we can lose, right? We should note that our player doesn't move outside of the screen, right? And you can press the right or left key once, and your player will keep on moving. And once an alien reaches the vertical level of your spaceship, that means that you've been invaded and you have lost.
Okay, so now that we have a window initialized, let's actually start putting our player on the window, and actually we'll start off with getting our player to move, right? I think that is a good starting point for us. So as we know, to actually get something to display on the screen in Pygame, what we need to do is just make a variable. This is the player. I think we can just call it player, and then we want to load in an image. The image that we've decided on is spaceship, right? So that's pretty cool. I am just going to get the relative path, right? That is copied, and there we go. And yeah, so we can then decide the position of this that we want to spawn the spaceship in, right? So what could that be? Let's just go down here and let's just screen, because screen blit is what we use to display something. I'm just gonna screen blit player, and as we said before, the top left corner is 0, 0, and and so Y increases like this, X increases like this. So what can I make it? Because it's 900 by 600. I'm gonna make the X-axis, let's say 450, and the Y-axis, let's keep it at 400. Right? We can change this later if this is 400 is too high. I'm gonna keep it at 5. We have to change these slashes. Yeah, there we go. That should be good. Okay, so 550 is too low. I will get out of this. Post program. 550 is too low because we have to take into account that the image we downloaded was, I think, 64 by 64, right? So yeah, that would explain why. Yeah, so let's just make it 500 then. Okay, nice and simple. There we go. Yep, so now we can see our image. That is great. That is us, right? And we're gonna be kicking some alien ass. Right, okay, now what we want to do is we want to get the movements down, right? And now this is a really interesting part. So how can we do this? Now, in Pygame, we want to be detecting the key clicks, right? So in Pygame, how this happens is that a key click is an event, right? So we want to detect an event. So first of all, we have to initialize a for loop, which goes through all the events that can be detected in our current Pygame, right? Is it events? Event.get, right? That helps us get all the events that are occurring, right? And then we can say if event dot type, event dot type is equal to dot key down, right? So key down is when we're pressing a key, and key up is when we release a key, right? So key down, then key down, so that means that we've pressed a key, and that is an event. Now we want to define the type of key we've pressed, right? So for that, we can say event dot key. I think that is a thing. Event dot key. Yeah, we should be good. Yeah, event dot key is equal to pygame dot. There we go. So now we have up, left, left, up, right, and down. No wait, key down. Key down should, yeah, there we go, key down. Okay, I just had to check. We're not gonna be using key down right now, but I just had to check. So, yeah, we'll do key right first, right? Key right, and then what we want to do is player. Okay, yeah. So this, now we're creating the movement of the player, right? And for this, what we have to do is we have to change the position of the player, right? By a certain X and Y value. So first, let's initialize the players starting X and Y, right? Player start X is equal to, we decided it would be 450, and player start Y, we decided would be 500. Okay, and then let's decide how much of a horizontal change we want to give our player, right? So we can just name that variable something like player X or player delta X, right? Because that's usually change in X. So player delta X. Now this too, we'll just observe how fast it moves or how slow it moves. But I'll start with 20 pixels, right? And that should, I think that'll be okay, but we'll see how it goes. And then we can just say player start X. Maybe I shouldn't call it player start because that's gonna be the variable for all of them. So I'll just say player X and player Y. Okay. Player X plus equal to, because we're going right, so that is an increase in our along our horizontal axis. So I'll just, yeah, that's a plus, and player delta X. There we go. And elif event.key is equal to pygame.key left. Yeah. Then player X minus equal to, because now we're going left to the left of our x-axis, is equal to player delta X. So right here, we're always, no matter a change in our X and Y, we're always initializing our player at 450, 500, right? So I think an easy fix would just be player X and player Y, just setting it like that, right? And now we should see some change. If I can just close this. There we go. See? So we can change it, right? And with every key, it moves 20. And honestly, I think that's pretty good. Great, so we have our player moving. Okay, so we saw that we have the player movement implemented, right? But really, when I move this around like this isn't the ideal movement that I want. I want something more continuous, you know, like you press it and then it just keeps on going, but I have to click every time now, like that. And okay, sure, yeah, some people might like it, but this is not what I'm going for. I want a more smooth movement, right? And another problem that I'm irritated by is that when I just click this, it doesn't end, right? I have to go into Task Manager and end the task manually. Now that's not great. So those are two things that we're going to be fixing right now. Now, I think there is an event in Pygame called quit. So what we're going to do is, in our loop that goes through all the events in Pygame, we're going to say if event type is equal to pygame.quit, then we are going to quit. But how do we quit, right? Because, we want to break out of this while loop. And how do we do that? Well, okay. So instead of just having it while true, as we know, we already have 3 conditions at which the game should end. Now we just have one more, right? We just have a 4th condition. So we'll just make a variable called running and set that to be true, because that's what we wanted to start. And inside this condition, where a condition for a game to end is if the player just rage quits, right? Oh my gosh, Space Invaders is too hard. I don't know. But what if they rage quit, right? So then we just set running to be false. Now this is what we're going to do for all our other conditions, right? We're just going to be setting running to false once those become true. And I think we also have to add in pygame dot quit, I think. Yeah, there we go. Yeah, pygame dot quit. And I think that should allow us to actually successfully quit a game. Did I change this? Yep. Let's see. Hello, bye-bye. Bam. Okay, so that's one of the things I wanted to fix. And the second one is the player movement. Now the player movement, I think, is that we're decrementing or incrementing the player's X position when it's pressed down, right? But we want it to happen even after it's been pressed down once, right? Like this is one press down, okay? But we want it to keep on happening while we have it pressed down. So what can we do for that? Well, a solution is that instead of changing the player XY every time it's pressed, every time a key is pressed, we can just set the delta X, the player delta X, once we press a key, right? So let's see. Instead of initializing it over here, I'm going to set this to 0, and inside I'm going to set this to player delta X, right? I'm going to set this to 20 because, right, going like this, right? And I think 20 will be too fast if it's like that. So let's go something like 10, and then as I said before, we can just play around with that. Player delta delta X is equal to -10. Okay, and then what we want is that even after that player event, yeah. So right here we're going to be setting player X plus equal to player delta X. Pressing the key sets the player delta X, right? But lifting from the key should also set the player delta X, right? Because we want it so that once I lift my finger up from the key, it shouldn't move. And when will it not move? When player delta X is 0, right? When it's pressed down, for every iteration of a while loop, for every iteration of that for loop, for every iteration of that while loop, we wanted to read that, oh yes, the left key or right key is pressed down, so I'm going to set player delta X to a number, right? But once we lift it up, for that iteration, it's going to read, oh wait, now it's not lifted, now it's not pressed. So let me set player delta X for this iteration to 0, and at that point, it's not going to move, right? So hopefully that makes sense. But yeah, so we need to create another conditional, is equal to pi game dot key up. If that happens, and then if event dot key is equal to pi game dot k right, or event because regardless, when we lift any one of those, we want to stop the player from moving, is equal to pi game dot key left. Then player delta x should be 0. Okay, that is that. And I'm going to change this. What do you think? Like 1?
What do you think? Like 1?
I guess. Okay, so it looks like we now have our player movement done, right? It's moving as we want it to. Yeah, nice and smooth. So what we want to start doing now is we want to start spawning the aliens, right? As we discussed earlier, we want there to be 6 aliens, right? And instead of making each alien an individual variable, just like we did with the player, so instead of making it like alien 1, alien 2, alien 3, like that, what we want to do is we want to make use of arrays or lists and really compress that process, right? So what this allows us to do is store all the aliens into one array, store the x coordinates of the aliens into one array. Yep, that's one list. The y of all the aliens is in one list. And the alien delta y, because the aliens only move along the y-axis, is also one list, right? See, so imagine how many lines it would have covered if we did each alien, like a single alien a line, right? Like if we did every alien like this, right? That would be a lot of initialization. Now we want to randomly initialize the coordinates at which the alien is going to spawn. And for that, we're going to be using the random library. But before that, we want to use a for loop so that we can actually insert the images of the aliens into the aliens array, and insert the x and y coordinates into the respective lists, right? So let's get doing that. So we'll just get started with the for loop. So for I in range 6, and then we just want to append the image that we're going to be using for the alien. Well, I'm just going to copy the path from up there. Assets UFO.png. Yep, there we go. Then I want to append the x coordinates. So aliens x dot append. As we said, we want it to be a random variable. A random number within a range. So we're going to be using a random library and use its randint function. Right, we're going to provide it a range, and we want it to be so that along the x-axis, the alien isn't spawned outside of the window, right? So because we know that the alien has a size of 64 by 64, and the coordinates for the image also starts at the top left corner, and the coordinates for our pi-game window also start at the top left corner, right? So when we think about that, we can understand that, okay, our minimum x can be 0, okay? Because that means that it's going to be exactly at the border, but it's not going to be cut off. But our maximum x has to be 64 less than the actual limit we've set, which is 900. Right, so that is 836. Yeah. I will just put that in, right? 836. We will just check my math later, probably. And aliens y append. Now this, we don't mind if the alien appears somewhere a bit outside of our window. You know, like really, we could actually keep it. Yeah, sorry, we don't mind if it appears a bit outside our window. But anyways, because the top is 0, 0, I don't think it's actually gonna show up like outside of the window, so that shouldn't be a problem. But what we need to decide here is our maximum Y value, right? Because we only want because we've decided that once the alien reaches the level of the spaceship, we've lost the game, right? So aliens, just correct that, yeah. So we've understand that the maximum Y can, the minimum Y can be 0, and the maximum Y can be, because the spaceship is 500, so we don't want it to reach the spaceship's level. So once this is an alien, this is a spaceship, once it comes in line, you know, that's over, that's game over. So we're going to make this 500. Okay, hopefully that's all right. And we'll also make the delta Y randomized, but the range will be a bit smaller than than the actual. So what we can do is we know that one seems slow enough, right? One is good enough when we're controlling it. But and again, we can look at how it goes and then change it up. But I'm just trying to, you know, apply my own estimation that it might be a bit too fast if it's just continuously falling, right? We might not get enough time. So what we will do is we'll make .append rand int 3 to 20, right? Because we can only put ints 3 to 1. I'll make it 3 to 10, and then we'll just multiply this by 0.1, right? Then again, we want this all to be an int, so I'll just cast it for safety purposes, because I'm pretty sure rand, yeah, see, so in randint, both the parameters have to be integers, and it's going to return int too, right? So yeah, this should be all right. Okay, we have, you know, inserted the image, randomly initialized the coordinates. Yeah, that's good. So now what we want to do is we want to update the display, right? Similar logic to you know, initializing the aliens. We're going to go through all the coordinates and all the aliens, which are 6, right? So for I in range 6. What we want to do is we want to screen blit. Sorry, TyGame.screenBlit. Or sorry, it's just screen.blit. Screen.blit. Here it is going to be the aliens at I, and then we have to make a tuple of the coordinates, which is aliens at x. Sorry, aliens x at I, aliens y at I. Okay, so and then we can just decrease the y. So aliens y at I minus equal to aliens delta y at I. Right, so this is just going to decrease. Yeah, it's just going to decrease that. Decrease the y by. Oh, sorry, we want to increase the y. We want to increase the y. Yeah, because it's 0 and this is 6. This is 600. I want to see the effect of this. I think we should be all right. Right now, when we do this, right? My expectation incorrectly so, but my expectation was that, oh, I'd get to see the aliens moving, right? But that did not happen. Yeah, see, so all the aliens, they're just standing in place. But to do that, what I want to check out is what makes them move is their delta Y's, right? So let's see what I'm just going to make say print aliens delta Y, and I think we can find out the problem from here, right? So see, all of the aliens delta Y, they're all 0, right? And so now I see my mistake is casting it to an int, right? I needed these to be integers, but I don't need the aliens delta Y to be integers, right? That is, those being floats is not a problem. So we can just get rid of the int casting and we should be good. Because what happens in the casting is that if it's a decimal, if it's something like 0.3 or 0.4 or something like that, then it's just going to be become 0, right? Because it just gets rid of the decimal, the number after the decimal. So that's where our problem was. It's still very fast. So I think we have to limit it to something like 1 and 8 maybe, something like that. What would that be too fast too? Okay, yeah. And we also want to decrease the vertical limit at which they can be spawned. We'll just keep it something like 100. We just want them to be scattered. Okay. And we'll keep this one to 5. There we go. I think shoot that. Okay, I still lost, but yeah. So we have the alien movement now. But since we have the aliens coming down to the spaceship's level, I think we should first just get done with. We can implement a few of the game-ending conditions, right? So what we want to do is the first thing we want to check in this for loop is if aliens at aliens x at I is equal to player x and aliens aliens y I is equal to player y. Then that means right now I'm just going to print and game and we are going to make running to be false. Okay, and we're going to make running false, and we're going to break out of this for loop because we just want to quit as soon as possible. Okay, so that's one of the conditions we talked about. Two of the conditions to ending a game depend on the position of the alien, right? So clearly we implemented this one. Now we just need to implement. We can just do this, right? And I think, yeah, I think this is good enough. Because so look at it, right? If the alien is on the Y level of the spaceship, then it's already going to end, regardless of if they're overlapping or not. So really, I think it's okay if I think this if statement, this condition should be good. So I'm just gonna let them reach. That worked. Okay, so now that we have one of the game ending statements, we also have the alien movement, we have the player movement, right? So what's left? We need the aliens to die. And how will the aliens die? Well, if we shoot a bullet at them, right? And if they make contact. So first, what we really want to do is we want to determine, we want to just initialize the bullet's values first, right? So bullet is equal to pygame.image.load space invaders. I'm just trying to copy the relative path right here. I will have to change the slashes right there. That is good. And then, so we're gonna initialize these. We're gonna initialize bullet X and bullet Y to 0 right now. And bullet delta. So only the Y of bullet can change, right? Is 0 right now too. No, we can actually keep the delta Y of this constant. And I think the bullet should be pretty fast, right? So let's actually make it something like, let's keep it at 2 for now. Okay, and then we'll see how that goes. Now, so we have to decide what key we want to use to first of all, like, fire the bullet, right? And I'm thinking we could use something like the spacebar because I feel like that's pretty common. That's also easy to reach, right? I mean, like, the second hand can be on the space bar, and while the other hand controls the arrow keys, something like that. Or we could also have the up key. Yeah, okay. You know what? Let's use. Oh wait, we're already using key up. Oh wait, no, sorry, yeah. So let's use key up to shoot the bullets, right? So that's only one hand. I think that'll be easy control. So what I'm gonna do is, I think all of these. So we want to recognize all the keys pressed, right? We don't want to ignore any of them. So I think just having ifs, so all of them are, all of them are, are recognized even after one of the statements, if one of the conditional statements is true. So yeah, so we'll make all of them ifs, right? And then pygame dot key up. And then what's going to happen is that bullet X is equal to player X at that point. Screen.bullet and bullet. What's the name of it? It is bullet. Okay, there we go. And tuple bullet X bullet Y. Okay. And bullet Y should also be player X, player Y, right? So by putting the screen bullet here, what happens is that the bullet is only displayed when we click key up, right? So we want to take this out of here and just place it right here. So this is what's going to happen because of that, right? So we're moving around. But yeah, okay, so now even when we move around, our bullet is still going to be displayed, right? So that's a problem solved. Now, what we want to do is we want to make the bullet move, okay? We only want, and to make the bullet move, we need to decrement the bullet Y, right? And we only want this to happen when a bullet has been shot before, okay? And we also want to make sure that the player is only shooting one bullet at a time, right? So let's see how we can do that. Now, of course, we're going to need an if statement for that and a boolean, right? Let's make a boolean right here that says something like bullet shot. False. That's how we are going to start out, right? And bullet shot will become true when we press key up, right? Shot, there we go. Then we are going to put this inside an if statement that if, because if I put screen blit here, then bullet X is initialized as 0, bullet Y is initialized at 0, right? So even when the game starts, the bullet is always going to be on the top left corner, right? But we only want it to display once we've clicked up, right? So if bullet shot is true, then we want to display, and we want bullet Y minus equal to, because it's decreasing as it goes up, bullet delta Y. Okay, that seems to be all right. So now let's just make sure that, you know, it does go up. Wait, what happened right here? Bullet Y if bullet shot. Oh. I see what happened. Bullet shot is equal true. There we go. Yay! Okay, that works. Okay, so we have our bullet moving. Now, what we want to do is two things. As we said, we only want to shoot one bullet at a time, right? So we should only be able to shoot our second bullet once the first bullet is out of the screen, right? Out of the screen or in contact, but yeah. So what we can do is before this, before bullet shot, we can have an if statement that checks if bullet Y is less than 0, or equal to, you know, maybe we'll just make it like disappear once, yeah. So then we want bullet shot to be false, right? And we also only want this to happen if bullet shot is equal to false. So let's just make this not bullet shot. So if the bullet isn't shot, then we want this to work, right? That makes sense. Okay, if it is less than, yeah. Oh, if not bullet shot. Oh no, sorry, wrong syntax. Not bullet shot. See, so even while the bullet doesn't go, till the bullet hasn't reached the top, I can't shoot another bullet. Okay, that happened, and all the aliens passed through. So this is a recurring problem, right? So that ended, but then so when you're simultaneously doing something else, it seems that it's skipping over the game end statement or something like that. So the problem with that is that with the decrements we're doing, the aliens Y might not always be exactly equal to the spaceship's Y, right? And so when that doesn't happen, even if the alien goes past it, it's still the game still continues. So to change that, what we can just do is just make it greater than or equal to. Yeah, I keep on forgetting the coordinates of pi game. Okay, so now, okay, yeah, that worked. Okay. So I think that fixes it. Now I think we should work on bullet collision, right? So we've made it so that our bullet is being shot, I think the speed is okay. We'll actually have to, I think we'll still have to decrease the alien speed because they're going way too fast for it to be a competitive game, right? But yeah, now I think we should work on the collision of the bullet and the aliens. And for this, we're going to have to use, we're going to have to calculate the distance and just figure out an approximate distance we want our bullet and alien to be, right? Because we can't we can't rely on the bullet being like exactly equal to the alien's coordinates, right? But we want to allow an approximate. So let's see, what should we do? So let's just see what actually happens if the bullet XY, if we say that the alien is only killed if bullet XY is equal to alien XY, right? Let's see what happens. And now where should we be doing this, right? I think in here we want to decide that if the bullet XY is equal to alien XY, then we don't display the alien, right? Because that means it's dead. So let's see, if bullet X is equal to aliens XI and bullet Y is equal to aliens YI. Okay. And we also need to make sure that bullet has been shot, right? Yeah. So what do we need that though? Bullet has been shot. Yeah. So what I'm trying to do with this is that I'm trying to avoid something like the bullet continues to go after it's hit an alien, and the same bullet kills like multiple aliens, right? So I'm not trying to let that happen, because what I'm thinking when I just think about the logic is that what would happen is if we don't turn bullet shot to false here, then in the next run through of the while loop, the bullet is still going to continue on its course of action. And then that's going to lead to one bullet killing multiple aliens, right? So bullet shot, and then we're gonna say bullet shot is equal to false. We're gonna set it to false. Now the way to kill an alien, what I'm thinking is that I'm just going to make it vanish off the screen, right? So I was just thinking that I'd make it. I just make the alien XY to some coordinate off the screen. But let's see. Let's see how that works. So yeah, I think that's the best way to do it, is that we just set aliens XI equal to something that is off the grid, which we'll just make like 1,000 aliens Y 1,000. So I keep on making the double equals for some reason. 1,000, and we are going, because now we don't even want the alien to like move downwards, right? So we have to make aliens Y delta Y at I equal to 0. Okay, we haven't set up the set it up so that an alien dies if the bullet touches the alien, right? Right now it depends on the alien X and the bullet X and the alien Y and the bullet Y being exactly the same, right? But we want to make it so that it's in the vicinity, right? Because, so I'll actually draw it on the whiteboard and try and explain what's up. Suppose this is the alien, right? Then its coordinate is, I think, on the its coordinate is on its top left corner, right? So this is the alien X and alien Y, right? So you can imagine how hard, and for the bullet, it's the same, right? This is bullet X and bullet Y. So you can imagine how precise we'd actually have to be for both of those to be equal. So what we're going to do is we're going to implement something in the sorts of like an is collision function, and just find the distance between these 2 points, right? And we want to make it so that if we visually can see that, oh yeah, the images are touching, then this should mean that the alien is dead. Okay, that's what we're going to try and implement. So let's see what we can do. Let's see what we can cook up. So def, I think I should do it right here. Def is collision. And for this we need alien X, alien Y, bullet X, bullet Y. And we're going to just calculate the distance between those two points. And for that we can use math. I think we'll need to import the math library too now. Import math. There we go. Import math. Yeah, I don't think we need to install this. I think this comes in like by default with the Python installation. Because I've never had to do pip install math. So I think y'all should be all ready too. But yeah, math and then square root. So square root math. I think we're just gonna square this. Yeah, that's how the distance works. Pow. Alien X minus bullet X and squared, right? That's power because I'll just refer to the distance formula I'm using if some of you are unaware. Something like this, x1 minus x2 squared plus y1 minus y2 squared, right? And this is the distance between 2 points. So that is some math for you. So let's just finish this, and then we can decide on the distance that's good enough. But that's for later. Plus math.pow alien y minus bullet y 2. Yeah. So I think that is good. And so what do we want the distance to be, right? Let's just try something random. Okay, so this is the top. So what I'm thinking is this is the top left. We know that our sprite is 64 by 64, right? And this is 32 by 32. I'm really just going to try random numbers and see what gives us like the best result, right? We're trying to look for the maximum number that gives us the most accurate collisions. So this is 0, and what distance do we want this to be? Let's just try something like, that's 64. Let's see, something like, let's just start big and go down and see what happens. If this is greater than 60 falls, so that means the collision hasn't happened. If this is less than or equal to 60. True. Right, there we go, that is that. And what we want to change is right here. So, I'm just trying to catch my train of thought again. Bullet shot. Bullet XY. Oh, right here, right. So collision. I think I can just change this with its collision. There we go. Oh, right, yes. Alien X. Aliens X at I. Aliens Y at I. Bullet X. Bullet Y. What the hell was that? Okay, I think to find out if I've actually killed an alien, I also need to determine the score. So let's actually implement the score, and then we can see. So score is equal to 0, right? Maybe I should do it somewhere here. For 30. And we'll just do print score. Return statement. I'm supposed to oh my. So really, hopefully, some of you coding along with us probably caught this, but I was not returning anything when I was expecting to return something, right? Like a boolean, but I just didn't write the return statements. Oh my god. Let's see what happens now. Okay, and see, so the bullet got within proximity, like we could see it, and the alien died, and the game ended. Now, why does the game end? Well, remember when we said that if aliens Y at I is greater than or equal to players Y? Well, that's exactly what's happened here, right? I made aliens Y 1000, which is greater than what the player's Y is, and so it died. So what we can do instead is we can just make it something like, we can just change the aliens X to 1000. I think that should work too. Let's see what happens now. Yay, we can actually kill the aliens. Let's go. Now, another thing we want to change is we want to make these slower, man. I'm not too good at games, so it's hard for me. I need this to be as one-sided as possible. Okay, so how far? Okay. Okay, so the game did end right there. Okay, that was good. But okay, let me just make. I'm just trying to see, like, oh, so that's too far. That's too far. Personally, I think it should be a bit closer. Right, so that was not aligned and it still hit. So let's try something. Okay, honestly, for this we can just do else. But let's try something along the lines of 40. So if the distance is greater than 40, then it's not hitting. If the distance is less than or equal to 40, then it is hitting. Right, let's see what happens now. Okay, I'm trying to see. That was very along the edge, like 2 bullets I hit there. I'm just gonna make it 30 and call it a day. I think 30 should be good enough. Really, like, I'm just eyeballing this, right? We get the mechanics behind this, and that's the point of it. Now I'm just eyeballing it so like I don't feel like I'm cheating the game. Right, okay. Pretty good. Pretty good. Okay, yeah, so now I can get behind that. Yeah, That's good. Let's just make sure that our scores are updating. Yeah, and yeah, let's just make sure our scores are updating. I'll just do that right. Oh. I'll just do that here. Print score. We're gonna make this display on the screen, but you know, just to make sure. Well, yep, 1. Okay. Yeah. Okay. Now again, I saw a bullet pass through it, but it didn't hit. So I'm going to increase it back to 40. I like 40. I think 40 is the most appropriate. You take that. Take that. Take that. Bam shabam. Okay. That is good. So now what we want to do is we want to implement the score is greater than 6, then the game is over condition, right? Now let's think about it. Where should we do that? Well, okay, really, it's just, honestly, I think somewhere right here would be good. If score is equal to 6, then we can print endgame, sorry, U1. We can say running is equal to false, and we can, well, no need to break there. I'll just print the score right here. Yippee! So we have officially completed a game of Space Invaders and we have won it. Okay. Now, so if I go back to our whiteboard, this has been implemented, this has been implemented, this has been implemented. We made the aliens and bullets contact. The aliens are randomly spawning. The alien speed, we've also made that random, so that's pretty lit. If you're a better gamer than me, then you know you can make him faster, you can make him slower, or you can make him slower, or you know give them a wider range. Spaceship moves along X. Spaceship shoots bullets. Yes. And okay, so now what we're trying to do is we are trying to display the score. So let's do that. So to display the score onto the screen, just like we defined our images, we have to define the font, right? So the font we're going to use is pygame.text, right? It is pygame.font dot and what can we name? What can we choose for name? Let's see. Okay, is that it? This font, okay. Nothing, still lame, but you know, if we feel like it, then we can go download external fonts and see what's up. Let's see. I think like something like a 32 font should be good enough. And then right here we want to do font dot render. So font is the font object we just created, right? And we want to render score is equal to plus we have to convert the score into string. There we go. So that is the message that we want to display. And then and then is the color value, right? So and then true, and then the color value. Let's just make it. I think this is gonna be white. Let's see. What's tonight is? I think it's 255. Yeah, because that's the RGB value. So let's see what it says now. Oh wait, I got a blit display. And now let's do screen.blit. Blit is equal to score disk. And this should be somewhere along 0. Let's say 0, 700. I don't know, I'm just throwing a number out there, or sorry, 700, 0. Hey, there we go. Yup. No. Fumbled. Okay. But yeah, I think that is pretty good. Oh, we're going outside of the screen. That's no good. But that's an easy fix. We have one. There we go. Let's go, guys. But yeah, I think that's an easy fix. And yeah, so let's just make it so that when we display player, I'm going to do it. I'm actually going to move this down here, just alongside. Yeah, I'll just do it right here, right? And if x, right? So if player x is greater than or equal to, so because it's the top left, even if it's equal to 900, then it's going to be outside. So if it's 836, right? So if it is greater, if it's greater than or equal to 836, right? And then once again, we can just change this around. Like we can just change it by a few pixels, depending on what we see. Then we just want to make player x equal to 836, or let's just say 835 or something. Let's see. Or no, 836 is good. 836. If player x is less than, so it's less than or equal to 0. Then what we want to do is player x is equal to 0. Yeah, I think that's good. Let's see. Yep, it stops there, and this stops there. Beautiful. Nice, guys. Okay. Now, I do realize that the game ending is a bit abrupt, so let's try and add some like layover text, right? Like if you win, it stays for a few seconds and then the window closes. If you lose, you lose, and it stays for a few seconds and then the window closes. So let's try that out. Okay, so I decided that, you know what, let's just do this thing the whole way. So what I'm going to do now is I'm going to download a .tff, I think it's called, file, which is a font file, which is going to let me customize my font and, you know, make this game even more cooler than it already is. So let's download a .tff file, font file. Yep, true font format. And then we're just going to move that into our, what do you call it, our assets folder. And then I think we should be good to go. Oh yes, this. this is what we need. Let's download that. Right, we are going to open in location. Unzip this file, extract it. Extract it. There we go. I'll just, you know what? Let's see what happens. Right, we're back to here. Well, it will say font. Copy the path. So let's see what happens. Oops. What happened right here? No such. Oh, I keep on forgetting that I have to change these. There we go. Oh wow, nice, nice, nice. Nice. That's sick. Okay, that's amazing. Yeah, so we can just use that. So we're going to create, that's our score font, let's call it. And our game font is just going to be bigger in size. Right? Hi game dot font. Remember, change these. And let's make it something like 64. Now what I'm going to do is, so this is our score. So this is our score font. There we go. That is that. Well, maybe you can change the color if you want. Now, when do we want to display these texts? Well, we want to display them when the game ends and when the game ends. And if we lose, let's make this clearer. You lost. Okay, and when we win, right? So just following standard font procedure, what we're going to do is we are going to create a game over font, right? And we are going to say font.render game over. You lost, something like that, right? True. Oh, gotta change this name to game font. True, and this is just the color we want it. I'll just keep it 255 for now, and then if we wanna tweak it later, you know, we can. And then we want to say screen blit, screen.blit, game over, and decide a coordinate. Now I'm thinking something like the center of the screen, maybe something like 50, oops, maybe something like 50, 0, 200, right? Let's try something like that. And the game, and like, it prints out and then it just exits, right? So we haven't changed that. Now something that I do think can change it is the time library. So what we can do is we can just pause our program for about like 2 seconds or for however long we want to display the message. So right here we are just going to do, we are just going to do a we want to do all the important stuff, and then we're just going to do time sleep, right? And here you just enter the number of seconds that you want to sleep for, right? You want the process to stop for. But what's going to happen now is that it's going to sleep, and it's going to wait to 2 seconds to update the display, right? So that effectively is still what was happening before for us, right? We can't see the text before our window dies. And so to remedy that, what we can do is just Pi game update display here. Right, sweet. That is that. And let's just do the same for game winning. Game over is equal to game font dot render game over. You won. You won. Me so happy. 255. 255. Just white. Screen blip. Game over. 50. This we still have to check really. But my game dot display dot update. Yeah. And time sleep. Yeah, time sleep 2. Let's see what happens now. So first we'll check losing the game, and then we'll check winning the game. Wow, that's incredibly slow. Game over, you lost. Okay, that looks better. It saved to 2 seconds. I actually got to see the text. That is pretty good. And now let's check winning the game. Nice. Let's go. Let's go. That's solid. That's solid. Okay, so I think we're done with that. Yeah, that's pretty good. Okay guys, so that was our tutorial for the game Space Invaders that we made in Pygame using, that we made in Python using Pygame, right? Hopefully you guys found that interesting as a good intro to Pygame to help you get more familiar with Python. Now, what you could do with this project if you're looking to make it more advanced and different, different to what we've done, different to what people online would have done, is you can add more features, right? You can add things like higher scores, that means more aliens. You can add a random number of aliens. You can also make it so that the user decides how many aliens they actually want. You can add different artillery to your spaceship, right? I've had friends in the past say stuff like, you know, maybe the spaceship should have a nuke or something like that that you get after like, you know, a certain score that you reached. You could add levels to this, right? So you can just expand on this game as much as you want and really dive into Pygame. So yeah, I hope this acted as a good introduction and hope you guys had fun, could follow along, and please remember to like and subscribe, and see you on the next one. Thanks.